This is section 5.1, practice A. We're going to look at numbers 13 through 17. We're going to place the figure in a coordinate plane, assign coordinates to each vertex. So you need a 4-unit by 7-unit rectangle with one vertex at the origin. So remember how we discussed this before. You're better off making your origin the lower left-hand corner. That way you're using quadrant 1. So if you want it to be a 4 by 7 unit rectangle, you can count over 7. You can count up 4. And there's your rectangle in the first quadrant. Assign coordinates for each vertex. Well, this is the origin. That ordered pair would then be 7, 0. This would be 0, 4. That guy would be 7, 4. And you can clearly connect those if you like. That's not the difficult part. We'll look at number 14 as well. We're going to make a square with a side length S and one vertex at the ordered pair S, 0. It's basically the same thing. You need to make use of the origin. Use the first quadrant. It just makes things easier for you. So where does S live? Well, I don't really know. Let's say S lives here. Your square is going to look like this. Now, if you look at the ordered pairs, this would definitely be S0. And this ordered pair would be 0S. This ordered pair would be SS. And S can be any number. I counted it out so that it was 5. It doesn't have to be 5. It can be any number. It can be 17. It could be 134. It really doesn't matter how long S is. But the idea is, here's a square, same width as that it has length in your coordinate plane. Number 15, place a figure in the coordinate plane, assign coordinates to each vertex. Explain the advantage of your placement. So we want a right triangle. I'm just going to take this paper and flip it over. Leg lengths 5 and 9. Well, the best place to put your right angle would be right there. You can count up 5 and 9 to the right, and there's your vertices. We have a 0, 0. We have a 9, 0. We have a 0, 5. An isosceles right triangle, you're going to do the same thing. This is number 16 now. You would put the right angle right here. You would count over 14 and up 14. That way it's isosceles. Number 17. We're going to describe a plan for this proof. We are given coordinates of the vertices of this triangle. Prove that triangle ABC is isosceles. Well, you can do this a bunch of different ways. Here's one way that I would do it. I would argue that this is horizontal and this is vertical. Obviously, it's on a coordinate plane. So these are right angles. So I would state that I have right angles here. And maybe I would call this point D, perhaps. Also, I would argue that this segment, AD, it's the same length as itself. Then I'm going to point out from point D to point B we went H units to the right, and from C to D we went H units to the left. So this length and this length are equal. So if I mark those congruent, notice how I have congruent segments here. I have congruent segments here, and I have right angles in between. These two triangles are congruent by side angle side. Well, if they're congruent by side angle side, doesn't that mean that their corresponding parts are congruent too? It does. That's what my plan would be. Now, you are going to need to put that into some type of words on your paper.